Right, today's lesson, we're going to look at cells and batteries. Now, as a starter, I've got here, complete the balanced equation for the reaction between zinc and copper sulfate. The reason I've done that is just to show you that when you have two different metals of different reactivity, there will be an electron transfer between them. And that's exactly what happens in a battery. So if we do the starter question, zinc plus copper sulfate, CuSO4, the zinc will displace the copper to make ZnSO4 plus copper. The ionic version of this is Zn plus, that's the spectator ion. So Cu2 plus, we've done this in the previous lesson, goes to Zn2 plus Cu. The key part is that there's an electron transfer. So the zinc is turning into a zinc ion by losing two electrons. So the principle is the more reactive metal will lose their electrons and give them to the less reactive metal, which in this case is copper. So the copper ion, in this case, will gain two electrons to make copper. So this electron transfer is what's going to drive the battery to produce electricity. Right, so I have taken your syllabus extras just to show you that a lot of this is, you should have to know it. So a battery contains chemicals which react to produce electricity. Fact. The potential difference or the voltage produced by a cell depends on different factors, including the type of electrode. So what two metals have you put for the difference in reactivity? And also the electrolyte, so what's inside is allowing the conductivity of ions. A cell can be made from two different metals in contact with an electrolyte, like you will see in my slide on the next slide. And a battery is when you have two or more cells connected together in series. And that gives you a greater voltage. Then we move on to non-rechargeable and rechargeable batteries. So these are just factual things. You need to know what it is. Okay, so we're going to be looking at these things today. And students need to be able to interpret data for these things. They don't need to know details of cells and batteries other than those specified up here. So let's have a look at a simple cell. A simple cell contains chemicals that react to produce electricity. A simple cell can be made by connecting two different metals with electrolytes. So here we have a lemon. We have two different nails, a copper and a zinc one. And the electrolyte is the lemon juice in the middle. So that allows the ions to flow. And the copper is less reactive, zinc is more reactive. So when you connect them, the zinc will spontaneously essentially be giving away its electrons to the copper. And it'll create a potential difference. That's what a cell is. Now, as I've already done this for you, the more reactive one is oxidized, so it loses the electrons. And the less reactive one is reduced. So it does this half equation here. Now, what factors can affect this potential difference is obviously the identity of the metals, so the electrodes. The bigger the difference in their reactivity, the bigger is going to be the voltage produced. The electrolyte is important, but you don't need to know how to quantify it. So you just need to know the electrolyte. You don't need to know if a higher concentration means more voltage. That's not something we can tell. Temperature is another one. Again, we don't need to quantify it. Surface area of the electrode is another one. Even the distance between the electrodes is another one. So these four, I would go for the top two and then the temperature one. As I say, the only one you need to be able to quantify is the first one, meaning you should know that the bigger the difference, the bigger the voltage. For the other ones, there's no specific rule. Okay, so there's 5 actually in total. I will be attaching this PowerPoint, but it will be in the notes as well. So here you got pictures of batteries. What's a battery? What's the difference between a cell and a battery? Well, a cell is this. A battery is when you have two or more cells connected in series. And here we have 3. Now, what's a non-rechargeable battery? Well, you should know an example is alkaline batteries. And you should know the definition. The definition is that the battery goes flat or it stops working when one chemical is used up. So one of the reactants is used up. So for example, in your remote control, once they stop working, you need to replace them. Now, rechargeable batteries like your iPhone can be recharged because the reaction is reversible. So when you plug your iPhone into the socket, what happens is the reaction reverses. So whatever reactants reacted at the beginning, whatever chemicals were reacting, they get regenerated when you plug it into the socket. Now you might say, why doesn't it last forever? Why does it degrade? The reason is that there's a catalytic surface that each time you charge it gets slightly damaged. So over time, the battery will degrade. An example here is a 6-voltage battery. This one is non-rechargeable, and it contains 4 cells of 1.5 volts. That's all you need to know on batteries and cells. That's it. Okay, so know the factors that affect the voltage and know the definitions of rechargeable and non-rechargeable. Next is the fuel cells topic. Now, people panic. What are these fuel cells? In essence, you need to know the definition of a fuel cell and 3 equations, followed by some pros and cons of fuel cells. So it's not a big deal. So if you look what students should be able to do for higher tier, write half equations. I'm going to show you 2 half equations. I would recommend that you only learn the acidic conditions, even if your textbook has the alkaline one. We've written to the exam board and they said you just need to know 1. You don't need to know both. And then you just need to know some pros and cons in the definition. So if we start with definition, fuel cells are supplied by an external source of fuel and oxygen. So the fuel gets oxidized within the fuel cell to produce a potential difference. Ultimately, you're looking at hydrogen and oxygen reacting to produce water. So you've got to understand that fuel cells are different to batteries. Batteries generate their own electricity by having a difference in reactivity between the 2 electrodes. A fuel cell actually needs a continuous supply of fuel and oxygen in a combustion reaction. And that's what produces the electrical energy. Okay, so the fuel is oxidized in a chemical reaction, and that's what creates the voltage. The battery doesn't have a fuel, it just has 2 electrons. The overall equation is that hydrogen and oxygen react to make water. Now, these are the half equations, and they might seem quite complicated. Ultimately, you need to memorize them. But I'm going to explain you how the process works and kind of build up the equations for you. One thing you'll notice here, do not panic, it says anode is negative. Now, in electrolysis, we learned panic. Positive anode, negative cathode. That wasn't wrong. But when you're dealing with these cells, it's the other way around. Now, in order to avoid confusion, you're not expected to know the word anode and cathode in the context of fuel cells and batteries. All you need to know is negative electrode and positive electrode. And as you well know, negative electrode is always going to be oxidation, and positive electrode is always going to be reduction. So normally, let me just make sure I've said that right, panic, positive is the anode. That's always oxidation, yes. And then negative is cathode. So the cathode is negative, so it'll attract cations, positive ions, which will always gain electrons. Yes, so that's true. So negative electron is always oxidation, and positive is always reduction. So you're adding the electrons on the left. Let me build it up for you. Okay. So from the left, we have H2 coming in. From the right, we have oxygen from the air coming in. What you do, as soon as the hydrogen comes in contact with this catalytic surface, is going to split. So the H2 is going to split into an H plus ion and an electron. But because it's H2, I'm going to double these. And this is the oxidation equation you need to know. Okay. When this breaks down into H+, the H+ can go through this semi-permeable membrane and across the electrolyte, but the H2 is not allowed to go through this surface. That is key. The electron will go through the wire up and across to here. So this was the negative electrode. And this is the positive electrode, which is going to be, as I told you before, reduction. So we've got negative and positive. Now, The electrons are going to float across to here. So obviously that's the other way around again, compared to electrolysis, where it's going to get from the positive to the negative. This is going the other way. Now, the electrons come here. So the oxygen is coming in from here. Electrons are coming in, and H plus ions are coming in. All three things are coming in, and they're making water. In order to balance this, because there's two oxygens here, we put a 2 here, which means that this is 4, and this is therefore 4, to balance the 4H plus. I can probably draw this a bit neater for you. And this is the reduction equation, okay? Memorize these two, okay? These two need to be memorized. So if someone says, what happens at the negative electrode? You would say hydrogen is oxidized to form H plus ions. What happens at the positive electrode? Then you say oxygen is reduced to form water. That's it, okay? So only the H plus ions can go through. This is key because the driving force of this reaction is that hydrogen, so this overall reaction, hydrogen and oxygen, they want to combine. That's quite a spontaneous process where hydrogen is extremely flammable. So these two are going to explode. It can cause an explosion if they come into contact. So now it's balanced. If you think about it, if you add these two up like simultaneous equations, this will be the final product because you would need to double this one in order for the electrons to cancel. And then when you add them up, it gives you this. But all you need to know is this, this, and this. Okay, and what happens, which one's the negative, which one's the positive electron. So learn them well. They're not going to ask you to describe how does the hydrogen fuel cell work. You just know the definition, continuous supply of fuel being oxidized to produce a potential difference, and you need to know these equations. Stick with the acidic conditions with H plus, and do not worry about the OH minus that you might see in the textbook. I will just save this. Okay, now I'm just going to look at the pros and cons. So clearly, because you produce water is good. So pros, no pollutants produced, just water vapor. They don't need to be electrically recharged, and they can be a range of sizes for different uses. The cons are that hydrogen is flammable. It's difficult to store hydrogen gas, so you have to store it under pressure. And sometimes, how do you get hydrogen? You can't just get it from the air. So if you produce it by electrolysis of water, and you use fossil fuels to do the electrolysis, then that's bad, okay? So that would be using a non-renewable source. If on the other hand, you use sunlight, solar energy, then that's good. So here are some examples of a zero emissions fuel cell bus that produces water, a fuel cell car, an actual fuel cell. This is how you can stack them on top of each other so they can give you a range of sizes and outputs of voltage. This is just a detailed hydrogen fuel cell car, all labeled. Obviously, you don't know it. Here, someone's filling up the hydrogen. Now, the other kind of con is that there's no infrastructure for hydrogen fuel cells. There's not like many hydrogen fuel stations, is there? There's petrol and diesel you see everywhere, and electric, but you don't see hydrogen. So the infrastructure is not quite there. This is like a detailed version again of pros and cons and notes on each one. So you can have a read through it, but I've gone over the main points already. So that brings to an end the hydrogen fuel cells lesson. Again, the PowerPoint will be there, and so will be my screenshot. So thank you for listening, and see you next time.